In a world of high-tech computing chips, Advanced Micro Devices, or AMD, provides high-performance computing power that runs everything from your gaming console and personal laptop to the giant supercomputers and AI systems that power the cloud.
AI is going to be pervasively infused into all forms of computing. And in the big cloud machines, it's the biggest AI. In the small client machines, it's very tiny, power-efficient AI that runs all the time, for example, but it's still AI.
This week, we hear from AMD's AI chief. I'm Jennifer Strong, and this is Shift.
Now here on the steering column is a device called Auto Cruise. You simply set the speed you want.
Self-driving robo-taxis are already on the road in US cities.
As the disk rotates, a mirror reflects the light in the way that depends on how the signal was recorded.
This is the 100 terabyte MCU. I present to you Electro, the Moto Man.
Ladies and gentlemen.
I would say that one of my greatest skills is my ability to interact with humans.
This episode, it's the latest installment of our oral history project.
From Zuckerman Spader. For 5 decades, Zuckerman Spader has been a leading litigation firm trusted by in-house and outside counsel, businesses, and individuals. With offices in Washington, Baltimore, New York, and Tampa, Zuckerman Spader serves clients throughout the country and around the world in high-stakes disputes, enforcement matters, investigations, and at trial. When the lawyer you choose matters most. Online at Zuckerman.com.
My name is Vamsi Boppana. I am the Senior Vice President for AI at AMD. I think I have the coolest job in the world, just living in the moment of AI evolution. But in terms of responsibilities, I run our data center GPU business and also our AI strategy and software and ecosystem efforts. AMD is a leader in providing high-performance computing solutions to the world. It's a 50-year-old company born right in the heart of Silicon Valley, making processors, which was what made Silicon Valley what it is today. And, for the longest time, I think provided processing technology for the general purpose markets. And in the past, call it 20 plus years, also has emerged as a leading provider of graphics processing technology, which is used for all things display, gaming, and so on. And most recently emerged to be a huge enabler for the AI revolution. So by virtue of that, is a significant provider of AI technologies. Even more recently, in the past 5 years, AMD did some significant business acquisitions, including the acquisition of Xilinx, which is a premier provider of programmable technologies for all kinds of markets. So when you put it all together, from processors, general purpose processors, to graphics processors, to FPGAs, adaptive SoCs, and networking technologies, it's one of the most important companies that's out there providing computing solutions to the world. Look, I grew up, studying computer science, so I'm a CS guy. That's where I did my undergrad college in the Indian Institute of Technology in India. And then, somewhere along the last few years of my college is when I got quite fascinated by all forms of computing. So I wanted to go do a PhD and had this wonderful opportunity to study fault-tolerant computing at the University of Illinois in Champaign. I had an advisor who was extremely flexible, super fortunate to have had an opportunity to work with him, kind of a free rein. I did a whole bunch of graph theory, right? I took graph theory classes 1, 2, 3, 4, and I was quite fascinated by theoretical computer science at the time. But it was all applied to making computers and chips run more reliably. So that's what I did my PhD work on. And then I came over to Silicon Valley, fascinated by, what can be done in the industry, and had an opportunity to work at Fujitsu Research Labs, which is actually quite interesting at the time. Fujitsu was an incredibly large company, but didn't really have research presence. So they actually got out to some of the colleges and picked up a few of us and said, hey, you guys, get to innovate. And it was a fantastic experience, right? Truly innovative Silicon Valley style experience where we created some, at the time, path-breaking technologies in formal verification, fault-tolerant computing. And towards the end of that is when a startup bug bit me, I guess. And, I ended up doing a startup here in the Valley. At the time, this was the late 90s, with the same basic physics underneath through which semiconductors were created. You could create a multi-gigahertz processor that Intel was creating, or you could create a 200 megahertz processor that was synthesizable to ARM, but the fundamentals were the same, right? So the difference was, how much customization you put in and how you tweaked every transistor and got the maximum performance or power efficiency out of it. And so our idea was at the time saying, hey, what if we were to take a few of those secrets that were going into this, extremely labor intensive manual work that was being tweaked and automate some of that? Wouldn't it be great if I take, the ARM processor that's running at 200 megahertz and maybe run it at 250 megahertz and offer more value to the marketplace? So that was the genesis of the company. And, after we took that company through an acquisition, I was maybe thinking of doing another. Then the call from Xilinx came, and the opportunity for Xilinx at the time was always a darling of Silicon Valley, but looking to figure out how to grow beyond the traditional markets Xilinx serviced. And the opportunity really was what was a traditionally hardware engineer friendly product and turn it into a software engineer friendly product, right? So in order to program Xilinx devices at the time, you had to write Verilog or VHDL or low level language code. And we at the time at Xilinx said, hey, what if you were able to take a ARM SoC and embed it right into an FPGA so that when an FPGA opens up and wakes up, you can actually write some C code, and a software engineer can suddenly access all the power of the FPGA as an accelerator. So it sounded super cool. And, it took us a little while to get them all adopted in the market, but they became extremely successful. And most products that Xilinx does today are actually software programmable from the get-go. So as that journey evolved, I stayed on and eventually ended up running all the products and programs at Xilinx. At the pure technology level, the reason I feel so special about this time is for almost, call it 5, 6, 7 decades, right? We used to compute things in a certain way, which is you have a piece of memory, you read some data, you process it, and you store it back, and you do it over and over again. It's a classical way of processing things. That's most general purpose programmability is like that. And of course, right, you do, some increasing levels of parallelism have emerged with multiple cores or multiple issues in an instruction and so on. And then you look at like what actually happens in the world when we are observing an image coming at us, right? We're not processing pixel 1, pixel 2, pixel 3, pixel 4, right? We're not processing it like that at all, right? We're just taking chunks of information. And that's how the biological intelligence inside of us is processing information. And says there's some contexts you derive by looking at all of it in parallel. And to some extent, right, neural processing is attempting to do some of it, right? Which is you take streams of things in parallel and extract information out of streams of things such that you take hugely parallel sets of decisions and keep moving the ball forward in terms of processing. So what's traditionally been a very sequential way of doing things becomes enormously parallel. So at the heart of neural processing, right, is that excitement that you could do things very, very differently. And that's why, when people said, hey, I used to process things in a large amount of time, now it's like significantly small, right? So, and then at a much more sort of deeper level, from even a philosophical level, right? For, I don't know, hundreds of thousands of years, biological intelligence has evolved in a certain way. And here comes this unique time in history where we're just starting to see the emergence of artificial intelligence, right? Machine intelligence. And so from this point forward, right, if you think we were in history, I don't know, millennia have passed, intelligence has evolved in a certain way. And here we are in 2025, all right? Or in these few years of time frame, there may be a very different way intelligence evolves, right? And it's quite remarkable if you step back and think about what is actually happening. We recognized some number of years ago, AI is going to be pervasively infused into all forms of computing because it's so foundational and it's going to cut across all forms of computing. And so we made it a core piece of our strategy to take the best AI and put it in the respective computing platforms that we offer for each of these marketplaces. And in the big cloud machines, it's the biggest AI. In the small client machines, it's very tiny, power efficient AI that runs all the time, for example, but it's still AI. And so my role at AMD is to think about sort of what this AI roadmap looks like for the company as we think about the cloud to the client to the edge and figure out, which products and which AI capabilities needs to be infused into these products and then deliver them. And then I also run a piece of our business, which is the cloud GPU business, which is extremely important for AMD. I think we are in the early innings of AI. There's a few people that have seen the ChatGPT inflection and what's happening in the GPU market. But in general, it's really still very early innings of AI. As we think about AI, get even more capable within the cloud, we will also see AI become much more prevalent in other computing platforms. PCs will have increasing amount of AI. And then over the long arc of time, all things embedded, whether it's factories or cars or, washing machines, right? All of these guys will have some level of AI. And so these arcs of AI is what we need to get prepared for. And they'll all get connected also together. So models will talk to other models that are on different, machines. Yeah, it's going to be a world that will have cooperative AI in a very distributed fashion. And so my group and I personally are super excited that we get to not only participate in this, but also shape the future of where this is going. I'm a very sort of positive person, very hopeful for our futures and, where it's going. So I would always say that, look, I truly believe that, the future that's going to unfold based on where we are is much brighter. So that's there. But I also feel simultaneously that we have a responsibility to ensure that it unfolds that way. Because if we do not, then it's easily possible to have unsafe AI or harmful things happen. So I would also say we all have a responsibility to ensure through careful evolution and careful regulation that AI has to evolve in a way that's beneficial and stays in a safe way for humanity. That's one thought I always sort of keep in mind. Saying, we always get excited by what we can build, but we have to ensure that it actually evolves in a very safe and responsible fashion.
This episode was produced by me and Emma Cillekens and mixed by Garret Lang, with original music from him and Jacob Gorski. Thanks for listening. I'm Jennifer Strong.